Okay, so this talk is entitled Manifest of Future Past because we're going to look at the future parser a bit more. It's considered an intermediate level talk, so we'll have a bit more code samples, and I'll do a bit more explaining. If there's any questions afterwards, like please ask or come find me during the hallway track. I'll be more than happy to help you out or explain anything further. This is the only X-Men reference I have in here, so if you soak it up for a second, and then we can go. So. I'm Danny. I've been involved in the Puppet community for about 5.5 years now. At various things. I first started off just as a user, then in my professional work, I kind of entered the community itself. I'm the maintainer of the PyPuppetDB library, which you can use to query PuppetDB. It's a Python library, because the Py. Puppet board, which is the front end that's built on top of PyPuppetDB. Both of them have been, slightly still as far as activity goes, but there's lots of cool stuff coming. I'm also halfway the unofficial maintainer of Puppet Labs apt. I work together with Morgan Haskell from Puppet Labs module team. So if you ever submitted a pull request to Puppet Labs apt, I'm probably the jackass that went, this isn't good enough. And last year during PuppetConf, we launched a bit of a project that we call Puppet Community. The idea is to have a community-managed space on GitHub where people can drop off their modules, especially if they've written a few but no longer need them or no longer feel to maintain them. They can hand them off to the community so that we can continue to develop them and that there's some continuity. So, the future parser. A bit of history, like the current parser sort of existed, and it basically started with Luke writing Puppet, and we needed a parser, and the parser is what the current parser currently is. But because there was never a formal definition of the language, the current parser has all kinds of weird and undefined behavior, including a bunch of bugs that are considered current or good behavior. So I think about 1.5 years ago, the effort started to rewrite the parser. Henrik Lindberg and Andy, who unfortunately left Puppet Labs by now, started this, and we have now actually a formal specification of the language and the new parser that goes with it. So based on that formal specification, if you should so choose to do so, you can actually write your own implementation of the Puppet parser in any kind of language, Java, C, Python, whatever floats your boat. One of the really cool things about the future parser is the type system, which is one of the things I'm actually going to focus on here. One of the things that the type system allows you to do is essentially type the input that you're going to get, which means that beforehand, before you do anything, when you get the data from your user, which can be in any kind of form, you will at least know a few things about that data. Most certainly the form that it takes. Like as a module author, and especially on, for example, Puppet Labs apt, it happens fairly often that someone comes in with a bug request and goes like, hey, or a bug, not a bug request. And it goes like, hey, I tried this, and in this scenario it works, and in that scenario it doesn't work. And you look at the example and you're like, yeah, well, our code was never designed to actually deal with the fact that you're passing in a hash here. It just so happens that, magically in that one case, because this one keyword mapped onto this magical other thing, it kind of worked. Now we can actually say like, okay, we accept only a string here, and if you pass a hash, Puppet will grab a clue bat and hit you over the head. One of the other really cool things that the future parser gives us because of the type system is we can get rid of all the validate stuff in stdlib. It's like validate hash, validate bool, is integer, is whatever. They can all go away because you actually know the type of a thing. You can define upfront that this should be of this type, and you can actually check that when you get some data in, even if you haven't typed it, of what type it is. No more create resources. I know that Kiara showed it this morning. He was like, hey, this is an awesome trick. And I totally agree. Except if you have the future parser at your availability, because you then don't need create resources anymore. Create resources was a bit of a hack because we never had any kind of way to do iteration in Puppet. So if you had an array or a hash of things that you wanted to create resources from, your only way to do it was to map that hash onto the resource type through create resources. Because we now have for loops, each is lambda, so you can actually do all of that natively in Puppet, which tends to also be more easier to read and for most people to reason about because you don't need to be aware of what create resources is actually doing underneath. So the type system. This is one of the basic examples. We have a variable, we want it to be a hash, and we assign the empty hash to it. If I would actually assign a number in there and would run this, Puppet would already go like, nah, we ain't doing this. A bit more complex is if you want to define something more about your hash. Let's say that, I want a hash, but this hash can only have 2 keys, and the keys need to be A and B. So you define a hash. As the first argument has an enum, which basically in enumeration, think of it as a list or a tuple. It says A and B, and that's your variable. So now, whenever you pass something in, you'll need to pass in a hash that has both key A and key B. The value in this case doesn't matter, but they just both need to be there. You can take that one step further, which gets to, you can compose types in all kinds of different ways for yourself. So you can actually create fairly complex kind of types that you want to, or definitions of types of what the data should look like. You can go completely through nested structures and so on. So structure, struct. What you define here is, again, a hash, but not with a hash keyword, but the struct keyword. The hash only allows you to define the first, the left side of the equation, what your keys should look like. If you want to define what your keys and their values should look like, you can use a struct. So here we're defining a hash again with key A and key B, and we're saying that key A must always be a Boolean, and key B must always be an integer. If you try to assign something that does not conform to this, Puppet will just tell you, no, sorry, whatever you're assigning to me right now is not equal to the type expression that you've given me. Bit more complicated. Struct again, hash, because hash is actually an incredibly useful type in Puppet, because you can do all kinds of really cool tricks with it. I have 2 keys that I've defined. Policy, which is an enum, which must be either of changed, always, daily, or weekly. This comes actually from Puppet Labs apt. It's like how you configure how often apt will automatically run the updates for you, or not at all. So that key must always be there, the policy, which is why we'll assign it. But we're also setting a second one, timeout, which we're given as an optional, which essentially means you can give this key to us. If you do, it must be an integer, and if you don't, then we won't care. It can be missing from the hash, and if you actually query for that value inside that hash, Puppet will just return an undef to you. Another really cool thing, which is especially useful when you're starting out doing a sort of future parser migration, is the variant type. With a variant, you can actually say, I need this to be of either integer or string. For example, we have a lot of places where you're allowed to pass in port numbers. A port number can either be passed in as an actual integer or as a string. In essence, I have a personal preference of passing it in as an integer because I think it's an integer. But some people tend to pass it in as a string, or for legacy reasons have it quoted in their higher data. So instead of actually saying, this can only be an integer, and then having Puppet go but I'm actually getting this thing, which is sort of an integer but not, but I'm getting it as a string, and then blow up on you, during your migration, you can actually say okay, I'm going to accept an integer and a string here. You can take that a bit further. A port, in this case, should be somewhere from 10,024 up to and including 65,536 for an integer. So if someone actually tries to assign the value 80 to this port, Puppet will again go nah, doesn't match, not valid according to the type that you've defined. And for string, we can kind of sort of do the same. We say the port number needs to be either 4 or 5 characters long. It doesn't give us the exact same granularity that the integer would give us, but you can still sort of limit the type of damage people can do. If someone tried to pass in a 6-digit port number, it wouldn't work as a string, or if you pass it in as port 80 as a string, 2 digits, wouldn't work either. Another fairly neat trick in the future parser is the defaults and splats. This is how you used to do resource default. If you wanted all files in one of your classes to get the owner, the group, and the mode exactly the same, you would define a resource default with the capital F for file, in this case, set the attributes, and then every file that you would have gets those attributes applied to it. Future parsing, we can change that. We can do this. You create a file block with the special called default, which then allows you to set owner, group, and mode, and then every other file that you define within that same block will get those attributes. Personally, I don't like this because I work in editors that have a lot of block editing functionalities, and especially needing to like change the trailing comma to like a trailing semicolon over there kind of messes you up. You can tend to get trailing semicolons in different places where you don't want them, and then the parser blows up. So what you can do instead is define it as a variable. So file etc, owner, group, and mode. You can define whatever attributes you want, and then the magical star with the arrow, or the fat arrow hash, which goes file etc. And essentially what it takes is do that hash, and just, for the idea is inline them as if you had defined the options over there. So everything will get your owner, your group, and your mode. You can do this in a whole bunch of places for any kind of attribute. If you define an attribute over there that is not valid according to the type, then Puppet will complain. So if I would say here like something like OGIS provider is whatever, and the file type does not support the OGIS providers, then it'll bill out for you. Cool trick about this is that you can take your defaults and put them at some kind of higher level in your Puppet code. So instead of defining your file default that you like to apply to so many of the code that you write in every single of those modules, because it's a variable, you can just define it at some kind of higher level in your hierarchy, like at the role level, or you have a company site profile, something like that. And you can just pull them in from there. So you can define them once for all the things that you need in your infrastructure. And when you need to update something, because your level of paranoia changes and you suddenly want your file types to be different, or someone somewhere signed a form that says like all files need now to be executable, you change one little bit and it'll apply cleanly everywhere. Also means you can do sort of cool injection tricks. Instead of defining it in Puppet, you can just define it in Hiera. Does the exact same thing. You don't even need to like expose it as a class parameter over there. You can just have like the Hiera call over here that just pulls in the data from Hiera. Now this is, if you think about it, this can be remarkably powerful because it allows people essentially to inject any kind of behavior into a class you write. So let's say that I have a class which writes a file, and I allow people as an option to tell me where to grab that file from. I provide a default, let's say like from within my module I have this thing that I believe should be what your file should look like. But if you want to, you can just pass in a new string that goes like puppet colon / / modules, my site module / my file, and you can take it in. If you now allow people to not just provide that string, but provide it as a hash, which takes a source attribute and anything else they need, they can essentially inject any kind of behavior in there, because you can just as well define a require in there, or a before, or a notifier, or a subscribe. So if you take this example far enough, you can actually create classes that by default do something same, but allow people to completely alter the behavior according to their needs without actually ever needing to go into your code. You can still wrap them in profiles, and you'll need to do so in order to like do exactly this little trick. But we can actually do it this way. It's a bit of a be very careful with this. Like it allows you to write extremely generic code and do all kinds of things, but because people can actually inject all kinds of behavior in it, there are places where you might not want to allow this. One of the other questions that comes up fairly often is, can I actually define my own type? Because as you saw, we had fairly complex type, like the struct with the array and the booleans and this and that. And especially if you have similar types across a bunch of modules, you'd rather define it once and then use it in a whole bunch of places. Right now, you can't, but we've had a lot of discussions about this, especially with Henrik Lindberg from Puppet Labs, and it's high on their list to actually get that done. It probably won't be in for Puppet 4, but I'm guessing 4.1 will get this. We'll actually be able to say like type, I don't know, type port is an integer from this to there, or type unprivileged port is an integer from this to there, type privileged port is an integer from this to there, and type port is a superset of both. And instead of then needing to like, you know, get that logic into every of your modules, you simply say like, okay, I expect this to be of type port, and you're done. There's always, the problem with moving to the future parser is that, you know, it's a big change. a lot of people, a lot of code, lots of stuff needs to get reviewed, and it's not very obvious to any kind of business, like is there any value for us in doing this, except for the fact that, you know, we need to follow the upgrade path and preferably not try to lag behind enough. So in order to give you an excuse to actually poke people to do this upgrade, we're going to look at one very cute little security bug in the current parser, which has been fixed in the future parser, and it's not really a security bug, but you can spin it this way, and it's magical because it'll allow you to push through any kind of change that you want. So it starts with this. Now, if anyone's been following the security, like Twitter bloggy thingies, they might have seen this example come up. A few people typed it like, oh my god, what did JavaScript do? And PHP, I can't clap slowly enough. Puppet being written in Ruby, unfortunately, is also sometimes inspired by PHP and JavaScript. So we have a similar bug. Now, if you look at these two things, we're taking the MD5 of that string and of the other string. And they're obviously two entirely different strings, so they should be two entirely different things that you get back as an MD5 hash. The current parser, however, thinks that these two MD5 hashes are entirely identical. Future parser, thankfully, does not. Reason, does anyone know? Like, does anyone remember the incident? Very good. Hash collision indeed, but not really. It's actually not a hash collision. You get two different hashes. But the thing is, Puppet, the current parser, does something which in PHP, for example, is referred to as type juggling. What you actually get back is these two strings. I hear an ah somewhere. What the current parser then does is it looks at the strings and goes like, huh, that's interesting. 0e something, that's a number. That's 0 times e to the power of the rest of it. So essentially, that first MD5 hash, according to the current parser, is 0. And as luck would have it, that second thing also starts with 0e to the power of something else. So the current parser, essentially, you're asking the current parser to tell you if 0 is equal to 0. And the current parser is like, yeah, pretty much. The future parser is smart enough to think like, okay, I'm getting a string back from this function, and I'm getting another string back from this from the same function. I'll actually compare them as a string. And goes like, okay, 0 and 0, same thing, fine. E and E, same thing. 4 and 8, not the same thing. These are not the same hashes. So this has been fixed, but it's a pretty neat little trick, and it allows you to, like, you know, look at it. There's something wrong with the MD5 hashes. We need to upgrade this thing. Now, the major issue is, of course, how you're actually going to do the damn rollout. Because if you think about it, it's really not that easy. You have the current parser, you have the future parser, you have your Puppet masters, by any chance, and you don't really have a way of going like, okay, I'll switch this over node by node or something like that. You switch it over master by master, because that's the one, you know, that's where you need to do it. So essentially, if you switch over your production master, everything just goes at once. So what a lot of people have been doing is like spinning up a new master and then moving out over agent, over agent, over agent. However, at Spotify, we actually run masterless, which allows us to do a whole bunch of fairly cool tricks. The reason we run masterless is not because the masters have a scalability issue. Like, we're up to 10,000 nodes, and we can scale our masters way past that. Scaling masters is not the issue. The new Puppet server makes this even a whole bunch easier. However, scaling the workflow was the issue for us. We have something at Spotify that we like to call aligned autonomy. Like, we have a fairly big company, lots of different units, lots of different squads that work on different things. And though we all work towards a common goal and have goals set by quarter, every squad essentially is fairly autonomous in what it does and how it works towards that goal. But if you have a big central Puppet code base, everyone still needs to regularly do work in there to update their services, to deploy services, to, I don't know, spin up new roles, new services in the infrastructure. So if we need to do a big bang release, we need to coordinate across at least 200 developers of like, okay, stop whatever you're doing, stop your code stuff, stop rolling out anything into production right now, because we're going to do this thing, and we're just going to, you know, take Puppet and like run tests for a week or two, and you won't be able to commit in the meantime, and then we'll start the rollout and like another week, and it doesn't work. Everyone works at their own pace, so we needed to find a way to do that. Running masterless kind of allows us to do this, because what we could do is switch the future parser on node by node or environment by environment. So what we first started doing is actually spinning up an instance of just about every role that we had in our cloud system and just running it. And obviously everything broke. Not everything, but stuff broke. But, you know, it didn't matter, because they were the separate instances that we were running, so we could find the bugs, we could patch the bugs, send in like the pull requests, move them through, and then, you know, the code was updated. So then, once we had done all that, we switched this on by default for our testing environment, and things broke. Because even though we had updated things in the meantime, other people had also submitted code that reintroduced certain bugs that we'd fixed before. But once you get that fixed, we could actually move over to the production environment. Now this was a process that all in all took us about, I think, less than a month at Spotify. We started mailing out fairly early about like, okay, hey, we're going to do this. And the testing move went by fairly quickly, and then we had the production move for another, where we did the rollout over about 2 weeks across our data centers. And obviously there was a bit of like a tail of, you know, we want to do things and like this broke and that broke, and hey, did you notice that this service isn't deploying anymore? So we had a fallback in place to the old parser. Like essentially we have a sort of YAML file that is read out by our Puppet wrapper script, which basically goes like, okay, turn these options on or off for this node. So for the nodes that were actually failing, and for the squads that didn't have time at that moment to actually look at, okay, we need to fix this Puppet code, they could just like set parser to the current parser. We could log a ticket about it and just look at it and fix it for them. One of the things that we found while doing this is that communication matters a fuck ton. Like, it doesn't matter how much you communicate, you will not have communicated this change enough. Especially if you have like 200, 300, 400 people that actually need to work on this. One of the things that we learned is, first of all, start really early with your communication, and try to actually use a mailing list that might reach a few people too many, instead of one that might reach a few not enough people. Like, especially for these kinds of changes, which are important changes, which are big changes, like make sure that everyone gets the gist, and not just gist, but like mail it out a couple of times, mail it out during the transition. We made that mistake where we announced it and then started the rollout fairly quickly, which caused some squads to not have caught up, and even some other squads that weren't on our internal Puppet mailing list and didn't see this. So that was slightly unfortunate, but we managed to work through it nonetheless. Stuff will go wrong. Like, it doesn't matter how good you are at doing this migration, how much effort you've done, how much testing you've done, something somewhere will go wrong. Someone will reintroduce a bug that you've already fixed. Some node will fall over, some data suddenly doesn't pass anymore because the future parser by default also does a bit of like type inference for you. So there might be places where things are just going to blow up that you didn't see in your testing environment. Being able to switch Puppet on and off quickly there, in that case, and prevent stuff from falling over is incredibly helpful. So if you have an orchestration system like mcollective, leverage it, or if you can do a slow rollout node by node, or at least environment by environment, use that capability. Regardless of that though, and how much you communicate, people will complain. There is absolutely no chance that people will not complain. Even if this went flawlessly, people would have complained about something. So, you know, do your best, and especially don't let this drag you down. Like, even if a service or two falls over, you know, even if Spotify goes down for a few days, no one will actually notice. So, but people will complain, and it's okay. Like, it happens, we make mistakes. But the thing is, like, learn from it. The things we learned is we needed to communicate more. And the other thing we learned is that we needed to keep track of more of the changes that were coming in because people were pulling in code faster than we could test it and fix it back up. The other thing we've also learned is that a lot of people weren't aware enough of the tricks or the benefits of the future parser. So we got a few things that go like, Jesus guys, did we really have to enable this experimental feature on like Spotify production in our production environments? And for us it was a simple yes, because it allows us to do, first of all, to get the type system in place, which allows us to squash a whole scala of bugs that we never have to worry about again. And it also allowed us to transition a whole bunch of ugly code to just, for loops, use all the new features, which makes our lives a lot easier. And we have a lot more beautiful, easy to maintain code. In the end though, like, no matter how much people complain, just remember that everything's actually pretty awesome. Like, it's really cool. Once you get this thing done, like, we managed to switch over about 10K nodes to the future parser. And we honestly didn't have to go through hell and back. Like, Spotify has a ridiculous amount of Puppet code. It's a huge repository with modules for just about everything you can imagine and deprecated services from years back. But we managed to pull this off with a fairly limited amount of actual RSpec tests and other things that verified behavior that we had. Like, one of the key things here was actually being able to just spin up machines in a cloud environment and see what would happen. If we hadn't been able to do that, this would have been like an impossible task. So all in all, we had a lot of fun. It was 4 weeks of bug squashing, of rolling it out, of getting feedback from users, of actually also seeing our Puppet runtimes improve because of the future parser. It does certain things smarter, function calls tend to be less expensive here and there. So overall, this was a pretty cool experience, and we now get to use all the amazing features that the future parser has to offer, which also means we get all the amazing bugs that the future parser has to offer. So we've actually been working on this for far much longer than 4 weeks. When we started, I've been running the future parser at my previous job and at Spotify continuously on our infrastructure just to see what's going to happen. And we found a whole bunch of bugs, which is to be expected. This is a completely new implementation. But one of the cool things about it is we found the damn bugs. So we could actually, poke people at Puppet Labs about, like, okay, we're seeing this behavior, and this is not what we would expect. We were seeing behavior where classes would get lost in like the resource graph that it would create and a whole bunch of other things. But because of those, like, people are very responsive to those actual bugs. If you tell them, you show a good code example of how they can reproduce it. Like, Henrik and Andy were overall faster in fixing the bugs that we found than us being able to find new bugs. So from, I think, 3.6 onwards, we had this continuous effort going about, okay, what's broken, what works, what doesn't work. And by 3.7.2, there was an implementation of the future parser that we could actually use. And that's when we decided to go for the actual last mile, 4 weeks of, okay, let's try and do this. And I think early December, this was done for us. So we've been running the Puppet future parser now for about 2 months, over the Christmas holidays and everything. Nothing went up in flames just yet. But it works. It's remarkably less painful than I expected it to be. Especially because of, like, the amount of, it feels really scary. It's this thing that interprets your code and changes it into machine code and changes it into commands. And this is a completely new implementation. But it damn well works. So actually, we're just going to move on to questions. So anything you'd like to know about how we did the rollout, what features we use?
Oh yeah. Oh no.
Run, Kara, run!
Oh no. Okay, there you go.
How long does Spotify have experience with Puppet in itself?
Let's see. So I've been there for a couple of months, but one of my colleagues is Eric Dalian. If you've been in the Puppet community, you might know of him. He's like a fairly regular contributor to Puppet Core, PuppetDB. They've been doing Spotify at Puppet for about 5 years, I think, 6 maybe even. Like, sort of the same amount of time that I've been involved. So we have a fair grip on the situation.
Thank you.
Anyone else?
Anything?
I don't think so.
Perfect, here we go.
Is the Puppet enforcing for existing types like file owner also the type? For example, you can use owner root or owner 0.
Yeah, correct.
Is there any enforcing? Root with quotes or without quotes?
No, right now I think Puppet still allows you to do whatever you want there. So you can put in an integer, you can put in root with quotes or without quotes. Style guide wise, if you're going to put in root, use the quotes. If you want to get less clashes with the BSD platforms, use the zeros instead, because they sometimes have a habit of renaming their root user to different things. So the zeros kind of work, but the parser doesn't enforce anything there for you. You can, as long as the type is happy to accept a 0 or a root or like a plain string, that'll work. But if you, for example, expose that as a parameter to your class and you define it as being an integer and someone tries to pass in root with or without quotes, that'll break.
You mentioned that you used Masterless Agents
Correct.
During the transition. Can you explain a little more as to how you did that? Because it wasn't really exactly clear to me. So you were using a master before, switched them to masterless, and then after the migration turned the master back on, or?
No, so actually Spotify's been running Puppet masterless for about 1.5 years or 2 now. So we transitioned to the masterless mode because we wanted to allow people to very easily prototype changes, and we didn't want to continuously have to spin up dynamic environments. Like if you look at our Git commits and the amount of branches that get created on the Puppet repository is like 10, 20, 30 things a day depending on which squad is working and which squad is rolling things out. So the dynamic environment thing didn't really scale for us. So instead what we switched over is to a setup which actually can download your fork of our Puppet repository or a specific branch of it, switch to that branch on that machine, and run Puppet standalone on that branch or run it on the normal production thing. So it allows you to completely prototype any kind of change without actually affecting the production setup at all. And one of the cool features that we had because of this masterless mode was that we could do the future parser transition fairly easily because we could change any single node at a time, change any single environment at a time.
But I assume you didn't change over each node individually.
No, so we did like a bunch of nodes that we thought like, okay, we should definitely try these out and see what happens. And then we did the other thing that I told you about is that for every role that we had, we actually spun up a machine, applied the classes, and looked at the output, corrected a whole bunch of there, and then we did the migration per environment. So we started with our testing environment, which is about 3,000 nodes, and then once that was all said and done for and we'd fixed any kind of bug that we found there, we moved on to the production environment, which we actually did data center by data center. So we have about 4 or 5 of them. So like over the period of 2 weeks, every 2 or 3 days we would switch a data center over, see what happens, and then move on to the next.
And your agents would simply retrieve the latest versions of your
our agents
from Git.
Yeah, our agents essentially when they start up, what they do is they like pull in the Puppet code, like from Git, from one of our Git mirrors. They clone it. They read a specific puppet.yaml file that we have, which configures Puppet in like the options that it needs to have, like where are your modules, which parser should I use, and then it starts up Puppet and runs it completely masterless. It does, in the end, report back to PuppetDB.
Okay. Well, thank you.
Back through.
Continue a question on the masterless mode. Doesn't that mean that every node has access to everything that's configured in Puppet, including security-sensitive material?
Very good question, thank you. Yes and no. So one of the things that we have in Spotify is that we have a special repository called our secrets repository. And getting access to those secrets is dependent on the roles that you have. So essentially, we map your client certificate and your roles. So whenever it's like a custom backend in Hira, which gets merged in, and it actually looks at your client certificate when you're requesting that data and the roles that you have according to PuppetDB, and depending on that, will actually give you certain secrets or not. So in a way, you do have access to the secrets repository. You can clone it, but like most parts, you won't be able to read it. And there's an API around it that allows developers to insert secrets into the secrets repository without being able to affect secrets from roles that they are not responsible for.
It's kind of the same question as was asked before. Sure. About the masterless mode. If you don't run masterless, you won't have any luxuries like Hira or ENCs or the like, but I assume you provision those facts the same way as you do with your secrets.
Yeah, so Hira works just the same for us. The only thing that it does is actually, when it's starting up, it just clones the Hira repository too. We have like a Hira data thing, which it just clones in together with the rest of the Puppet modules. So you actually get all the benefits of Hira, of PuppetDB that we have, because our agents are configured to report back to PuppetDB, but we don't have the central master that you need to go through.
So your agents collect their own Hira data?
Yes.
All right. Okay, thanks.
Balcony, anybody? Yeah,
Ooh.
why don't you shout it down and repeat it?
Could you provide a little bit more detail? You mentioned specifically that you were using cloud targets as part of what accelerated this whole activity for you. Could you provide a bit more detail? Was that just using them as sample targets to test things against, or how else can you use that to accelerate?
Okay, so the question is like, how do we leverage our cloudy environment to, help us accelerate the future parser move? Essentially, we have like a private cloud at Spotify, which is considered to be our testing environment. So within that private cloud, you can spin up any kind of machine at any time, and depending on how you tag that machine, it'll get one or multiple Puppet classes applied to it. So what essentially ended up happening is one ginormous for loop in a bash script, which went, for every role that we have defined here, please spin up a machine and apply those classes. And then we would actually do the human thing where we'd have to like log in, look at the see through PuppetDB if we got errors back, and if not, actually log in and verify that certain services were running. Some of those things were automated, but there was like a lot of manual work involved from both me and Eric Dalian to actually validate a lot of those things, which is one of the downsides of not having enough integration tests. Oh, yeah.
I wonder what kind of debug methods did you use while debugging your manifest?
So the question is debug methods for our manifests. One of the cool things about the future parser is that it has a habit of giving you significantly better error messages than the current parser. It will actually go far enough to tell you like something is wrong on this line and that character, and about 95% of the time it will be exactly where it tells you that the error lies. It might not be entirely obvious because sometimes it's because of data that's injected in there, but you'll at least get the variable so you'll get a sense of where this is coming from. For the rest, as most of the Puppet debugging goes, notice and notify will get you a very long way.
Oh yeah.
Can you just tell a little bit more about in the future parser, you don't need to create resources anymore. Can you tell us more about it? How?
Sure.
How would you go about replacing your creative resources?
Yeah. So the question is, I mentioned that in the future parser you don't need create resources anymore, and like how and why. So essentially, what the reason create resources exists is because you had no way to loop over any kind of data structure in Puppet. So if you wanted to define a data structure in Hira that went like, I want this file with these permissions or anything else, you would need to find some kind of way to pull in that data loop over that data, and for every of those entities that you have, a hash representing that resource, spawn that resource. Since you couldn't do that in Puppet, the create resources function was created, which takes as an argument the resource that you want to spawn and a hash of hashes representing that resource. It's essentially Ruby code that's basically doing, like, for every entry in this hash of resources, create a resource that looks like this. You can now just do this natively in Puppet because we have the each function, or you can call each on an array or on a hash. You can consume those hashes, you can reduce them, you can filter them. So you can actually process that data into a state in Puppet that you want, and then simply just use a normal for loop that goes like, okay, for each of these entries, give me a file where the first entry of the hash is like the file title, and then the second attribute, and just map them with a splat operator, or like explicitly write them out, like pull out the parts of data from the hash that you've given it. So you don't have to, like, you can continue using create resources, but I kind of prefer the explicitness of doing this in my Puppet code so that people can actually see like what this is doing. Okay, we're looping over a hash and we're creating resources, instead of mapping it and hiding the implementation details away in essentially Ruby. Does that answer your question?
Excellent. Thank you so much, Danny.